All right, let's finally get to that video I promised you about a Helix that has multiple entrances and exits. Now first though, I want to point out that this video is going to be very, very long. I believe my script for this is about 8 pages, and I go over a lot of information. One of the problems I have making these videos is trying to figure out how detailed I should get in my explanations. I try to make them with the idea that you are sitting right here with me and you're asking questions as I go along. And this means sometimes I will repeat myself or mention something over and over again that was in a previous video. The other problem I have is, if you just found this video and watched it as a standalone video, and I don't talk about a method that I used in a previous video, it might not make much sense to you. So I'm still going to repeat myself in all of my videos, but I have decided that starting with this video, I'll start including chapter points so you'll be able to jump around easier. Now, I hope they help, and I'll be adding them to other videos as well. Alright, so this Helix video came out of a track plan that I was considering for my railroad. Now, I got the bright idea that a multi-level railroad might work in the space that I had. The track plan I got from Model Railroader was basically a point-to-point plan, and I thought, well, maybe I can make this into a continuous run. Well, I did manage to do that using the Walther's Code 83 track from the AnyRail track library, but it didn't quite work out like I thought it would. And of course, in the true spirit of model railroad design problems, the plan just needed more space than I had, and I just couldn't make it work correctly. Now in this video, I'm going to use Peco's Streamline Code 100 track for the demo. Now why? Well, it's because the Peco curved turnouts in the AnyRail library appear to be accurately drawn. As for the Walther's Code 83 curved turnouts that are in the library, well, they appear to have some errors, at least as far as I can tell. Now, I'm not going to go over the problems with the Walthers in this video. I'll do a short video later on that explains what I found. And it might also point out some possible pitfalls you might run into in your design. Now, one thing I do want to point out is we're going to be using curved turnouts. And these turnouts use compound curves. Now what this means is you're not going to get a perfect circle of track in your Helix when you insert one of these curved switches. Now over here we have a Peco Streamline Code 100 SL87 curved turnout. And as you can see, the inner curve on this turnout is 762 millimeters, and the outer radius curve is 1524 millimeters. But being a compound curve, you can't simply attach, say, 762 millimeter curved track on this end and let it loop around back to this end, and you'll end up with a perfect circle. And that's because of this compound curve right in here. Now you'll note over here I wrote down compound curves, question mark, probably. And that's because when I first started looking at this turnout, I wasn't sure if it was a compound curve or not until I started playing with it. And then I dug into the Peco website a little more, and I found that it did indeed say that these are compound curves. Now, just because it's a compound curve doesn't mean that we can't massage our design to make our loops stack one on top of the other, and I'll show you how to do that in this video. Alright, let's start designing a Helix that uses 2 curved turnouts and has 4 places where track can come into or out of the Helix. Now I know that's overkill, but it's really going to demonstrate the design process for this type of Helix. So let's build the Helix this way. Now first I want to make sure that I have assigned some layers over here for the different parts of my Helix. Now this is very, very important because we need to be able to turn different parts of the Helix on and off as we do our design. So you can see I have the entrance, first loop, second loop, third loop, and fourth loop layers. So we're going to start with making the entrance layer our active layer. So let's go up there and click on it. And you'll notice I already have a piece of track on my entrance layer. And the reason I did that is because I needed to set my starting point for the rest of the Helix. And that way I know that the entire design I'm going to show you will fit onto the screen. So go ahead and you put in your entrance track, just like that. Now we're going to build our first loop. Now as I showed you before, the Peco switch we'll be using has an inner curve radius of 762 millimeters and an outer loop radius of 1,524 millimeters. We're going to be using the inner curve radius to make the loops in our helix. So let's make first loop our active layer, and we'll go grab a piece of flex track. Now we're going to curve it to 90 degrees and give it the same radius as the inner curve on our turnout. Now we're not going to put a turnout on this first loop. We're going to put the turnout on the second loop. So let's go up here, let's grab our piece of track, let's connect it here to the entrance track. Now I'm going to be turning this into a section and giving it a color. So let's come up here and hover over the connection point and say add isolator. That'll keep this track out of our section that we'll build. Now we're going to copy this guy with Control C, and we're going to paste it back in 3 times with Control V. All right, let's connect them up. And now we need to set the height of our first loop. Now I'm going to use 102 millimeters per loop for my rise, and that works out to just about 4 inches. So what I'll do here is I will go and select this last piece of track, right click, and say set height. And I'm going to set it to 102 millimeters. And now you'll see we have this grade of 8.5% here. So we'll hold down the shift key, select the first piece of track in the loop, come up here and say smooth slope. And that gives us a nice rise of 2.1%. Now let's create this first section. And we're going to name it first loop. And we're going to give it a color, and we'll give it the color brown. And there we go, there's our first loop. All right, now the fun is really going to begin. We're going to make second loop our active layer, just like that. And now we're going to select the first loop, but we're not going to select the entrance track, just the first loop. So I'm going to draw a box around it, like that. I'm going to copy it, and then I'm going to paste it back in. Move it over just a tiny bit like that. Now we need to set the heights for this loop. So I'm going to deselect it, select the first piece of track, set that to 102 millimeters. Go to the last piece of track, select it. If I can find it, there it is, set height, 204 millimeters. Hold down shift, grab the first piece. Oh, it didn't work that time. Let's go the other way. Sometimes it doesn't work. Sometimes it does, sometimes it doesn't. Let's grab this piece, hold down shift. There we go. Apply smooth slope, and we'll create a section. We're going to name this one second loop, and we'll give it the color red. Now, since we have the slope percentage and height displays turned on, you can confirm that this loop is at 2.1%, just like our first loop. All right, let's attach our second loop to the first loop. Bring it up here. And there we go. Now I want to point out that in this demonstration, I'm only building a 4-level helix. And I'm also bringing out the tracks every 4 inches or 102 millimeters. Now in the real world, you're going to need more loops, obviously, to get your helix up to the height that you want before you add in that loop with the turnout. Now the way we put in the turnout on this loop is very important because we're going to be using this loop for all of the succeeding loops that have turnouts in them. So you can think of this loop as kind of the template for the rest of your helix. And again, in this video, I'm going to put my turnout somewhere down here, kind of like what I did in video 38 when I brought the track out from down here. And what I want is I want to be able to come off of my helix this way with my turnout, bring my track up like this, and then curve it back like that. Now I showed you how to do that with the top loop in video 38. And if you did not see video 38, you might want to go back and take a look at it, because that video has an awful lot of information in it that we're going to be using in video 39. Okay, so let's go pick the turnout we want. In this case, we want a SL86 right-hand curved turnout. We're going to bring that in, and I like to rotate it like that, kind of in the position it's going to be, because it's just easier for my little brain to comprehend the end angles. You know, you may not have to do that, but it's something I have to do. And once again, I want to point out, I'm just showing you a way to do this helix. Now, my example probably would not, in fact, it would not be very useful in the real world. But you should be able to take everything I show you here and adapt it to your own design. All right, so we're going to put this turnout somewhere in here and bring our track out this way. So one of the first things we need to do is we need to come over here and turn off first loop. And then that way, when we're grabbing track over here, we know we are only grabbing track that's on the second loop. All right, I'm going to put my turnout in right about here. So I'm going to cut it right underneath that marker right there. So let's say cut flex here. And now I'm going to come up, grab this piece of track, right click, and I'm going to disconnect it. And I'm going to move it into the center like that. Now, we want the end of this part of the turnout, the larger curve, the 1524 millimeter, to match the angle at the end of this piece of track here. So what we'll do is we'll come up here and we will click on the end of this piece of track and look up above and see what our angle is. And it looks like our angle is 44.84 degrees. So we'll go ahead and write that down. And now we'll come over here. You know, let's turn off the height display so we can see those endpoints a little better. We'll come over here, we'll click on this, and we're going to set this angle to 44.84 degrees. Now, when we move this piece of track over, we have to figure out what the curve angle of this piece of track is going to be. And how we get that is like this. We select the end of our curved turnout and we look up above and we see what the angle is. And we see that it's 232.84 degrees. So go ahead and write down 232.84 or whatever you get. And then we're going to subtract 180 from that. So 232.84 minus 180 equals 52.84 degrees. So write that down. Now remember, you only have to do this once. If on every succeeding loop where you have a curved turnout, if you bring it out in the same place, you can just copy the previous loop and paste it back in. So you only have to do these calculations one time. All right, so we got 52.84. Now the next thing we need to do is disconnect this piece of track. Move it over here. We're going to be using that in just a second. Now, let's look at this end angle. And of course, it's 90 degrees because it's pointing this way. We use 90-degree curved sections in our loop. So this is obviously going to be 90 degrees. But you may not be using 90-degree curves. You might be using 45. You might be using some other value. So you have to go get this value. And this works if this point is back here or this point is over here. But for this demo, I made it easy and I put it at 90. Now, we want to subtract that 52.84 degrees from 90 degrees, and that gives us 37.16 degrees, and that's the curvature of this piece of track. So let's curve that. Now, I'd just like to point out in the last video, I made a mistake. I came up here and I clicked in the box right here. But as you can see, it's already highlighted. So I'm just going to type in 37.16. Hit OK. And the other thing you might want to remember to do, let me go back to curve flex, is just kind of make sure that you still have the same radius, 762. It shouldn't change. But, you know, just it's kind of a little safety feature. Just go ahead and make sure that it's still 762. All right. Now, we'll grab this piece of track here, and I can either connect it here or I can connect it here. Doesn't really matter. Now I'll bring this down, connect that up, and let's go look at our endpoint. And sure enough, it's 44.84 degrees, just like we wanted. Now before we build up our exit tracks coming off of that turnout, I'm going to take some time and show you something that you should be aware of. Now I mentioned the turnout is made out of compound curves. Now if I complete this section right here like this using 762 millimeter curves, I'll need to get the end angle at this point right here. and that's 32.84 degrees. Now I want this piece of track to curve up and go perfectly vertical back towards 0 degrees or 360 degrees, depending on how you want to look at it. And I really don't have to do any math here. This is 32.84, so all I have to do is come over here, select this guy, say curve, and set it to 32.84. Just like that. Oops, I was going to grab it, but I grabbed it in the wrong place. Let me undo that. Let's try grabbing in the right place. There we go. I'm going to connect it up right here. Pull this piece down and connect it. And now I've got the rest of my helix, but look up here. It's offset by almost the width of the track. And that's because of the compound curve down here. Now, if I keep adding copies of this loop to this point is going to start moving in farther and farther and farther. Now, this may not be a big deal to you. You could just make your sub roadbed wide enough to accommodate that. But it does start to get messy. Let me turn on the first loop, and there you go. You can see why that's messy right there. So let me show you a way to make everything line up correctly. But if you look here, you'll notice that loop 1 is on top of loop 2 here, and there's a good reason for that. Let me undo everything that we have done here. And the reason loop 1 was on top is this switch that we put in, I didn't set its elevation. And I'm not going to set its elevation until we complete our loop. So let's go ahead and complete our loop. Now the easiest way that I have found to do this is just simply grab this piece of track, connect it up. Let me turn off those heights again, and grab the end like so, connect it, select the track, hit smooth flex. And you'll notice down below that this piece of track went to 706 millimeters or thereabouts. And that works out to just about a 28-inch curve. So we went from what is essentially a 762 millimeter or 30-inch curve to a 706 millimeter or 28-inch curve right in this section here. And I don't think that's really going to give you any problems. If it does, well, then you can massage this and try and make it work out. But for me, I think I would just let that whole smaller radius here, I just let that slide. All right, let me turn my height back on. Oops, there we go. And we're going to smooth slope our loop. So let's select this piece right here. We're going to hold down Shift, smooth slope. And now we've got 2.1% all the way around our loop. And it applied the appropriate heights to our turnout. Okay, let's start building our exit tracks from the curved turnout. Now this is pretty much just like the method I showed you in video 38. We're going to go grab a piece of flex. And I'm going to take that flex and I'm going to put it up here somewhere. And I'm going to put it, say, right about there. Now let's go grab another piece of flex. And let's put it on the end of our turnout. If I can see it. There it is. I'm going to turn those heights off again. Now I'm going to grab this end, and while holding down Shift, because we want this track to go straight, I'm just going to cross it like that, up there. Now let's grab another piece of track, and this is the one that we're going to curve. So here we go, getting endpoint angles again. Let's go get this guy. And he is 44.84 because it's the same as the end of our turnout, so we're going to write that down. Then we'll come over here and we'll grab this endpoint. Of course, it's 90 degrees because track always comes in horizontally. Now in your design, this track may be rotated a little bit, but this will work no matter how the track is oriented. So we have 90 degrees here. And what we want to do is subtract this end angle from this end angle. And that gives us 45.16 degrees. So let's go grab this one and let's say curve. And we're going to curve it to 45.16 degrees. And let's stick with the 762 millimeter radius. So let's do that. And now we're just going to bring this guy over and we're going to align him up. And once again, I'll go grab this endpoint, go get my Y, 280.7. I'm going to copy that with Control C, come down here to this piece, and I'm going to paste that in with Control V, hit enter. And now this should be pretty well lined up, and all I have to do is move this guy over to match. Now you'll notice once again, this piece of track is on top of this piece of track. So we're going to set its height to 204 because that's the height we want it to be at when it comes out of this loop. And let's do this one as well. So give me a second. I'm going to go in and precisely align these two tracks, and then I'll be right back. Okay, that looked pretty good. Let's go back to track. And now I'll just simply cut these pieces like I showed you in the other video. Let's move that out of the way. Let's cut this one here. Let's disconnect. Let's grab this guy, let's drag it over. Let's hover over it. And it looks like it's a straight piece of flex. Now let's go grab this one. Let's hover over it. And it's got a 156,928.7 millimeter curve to it. I don't know what that is in inches, but I don't think that's anything that's going to bother you. Now we need to set our height and grade here, so let's turn height back on. And you'll notice we have 2.1% over here, but 2.8% here. Now I'd like this piece of track to be level at 204 millimeters. So what I'm going to do is I'm going to select this piece of track and this piece of track. And I'm going to set the grade from here to here. So let's smooth slope it. And now we've got 1.9%. And just like we did in video 38, we have a 2.1% here, and then it levels out to 1.9 here. So let's lose these pieces right here. They're no longer needed. And let's move on to adding the third loop of our helix. Okay, we're going to start making the third loop of our helix like this. We're going to make third loop our active layer. And since I don't need to see it right now, I'm going to turn off entrance. And that will make copying a lot easier. So let's come up here and let's copy the whole thing. Highlight it and hit Control C. I'm going to come over here and hit Control V. And it comes in kind of odd, but let's move it up. And now we need to set the beginning and ending heights for this loop and make it a section. So let's do that. Let's come over here and we're going to say this one is going to be, oops, try it that way. There we go. 204 millimeters. Okay. And then this one is going to be 306 millimeters. That wasn't a question. That was a statement of fact. Let's see if it will work this time. Hold down Shift, select it. There we go. We're going to smooth slope it, create section, and we're calling this third loop. And we'll give it the color orange. Now we'll move it over a little bit, and we want this ending point to now be at 306 millimeters. So let's do that. And once again, we'll select this piece and this piece, smooth slope it, and there we go, 1.9%. So let's go up here and attach it. And for some reason, we don't have this as part of our section. So let's see what happened there. Let's turn off height. And sure enough, there's this isolator there. There we go. Remove the isolator. Now it's part of that section again. Turn height back on. So we've added the two curved turnouts like I promised. So I can stop right here on this Helix design if I want to. But what about the end of this third loop? It ends right here and goes nowhere. So let's make this a little more complicated and add one more loop and one more exit to our Helix. Now our final loop is not going to have a turnout, but we still need to copy the entire third loop to make our fourth loop work out right. So what we'll do is we will copy the third loop here, and we're going to make fourth loop our active layer first. Then I'll come over here and I will highlight third loop. I'll do a Control C, come down here, do Control V, just like we did with everything else. I'm going to pull this up here like that now. Now, on this fourth loop, we simply want the train to come this way around the loop and then exit out here. So that means we're going to have to remove the track between here and take out our turnout. But for right now, we need those pieces of track because we need to get our grades set properly on this fourth loop. So what I'll do here is I will select this piece of track and I'm going to set its height to 306 millimeters. And then I'm going to select the last piece of track and set its height to 408 millimeters. Now I'll try and smooth slope it holding down Shift. Let's see if it works. And it did, so let's smooth slope it. We're not going to create a section yet. Okay, now that we have our grade set here, we're going to come over to this piece of track and we're going to set that piece of track to 408 millimeters as well. All right, now let's turn off the third loop. And now we'll start working on making our fourth loop the last loop with only an exit, but no turnout. But before we do that, I forgot, let's do this. Let's turn this into a section. So we're going to call this fourth loop. And we're going to give it the color yellow. Okay, here's where it's going to get a little bit weird, but it's the only way I've discovered so far to do this. Now, first off, don't worry about these grades right here. We're going to correct that in just a moment. So to set up this final turn of our Helix, we are going to come over here and we are going to delete this piece of track. We don't need it. Now this piece of track, we're going to disconnect. And we're going to pull it into the center here because we're going to use that piece of track in just a moment. Now, delete the turnout. And now we're going to grab the end of this piece of track and we're going to shorten it up. But first, let me turn off the height display. That's kind of in my way. So let me grab this. I'm going to hold down the Shift key so it goes in a straight line. I'm just going to make it shorter like that. So now we need a piece of track to replace our curved turnout. And that piece of track is going to go from here to here. But this track cannot be a constant radius curve because our turnout was a compound curve. So what do? Well, we're going to use our old friend, the easement track. Now, why are we using an easement track? Well, as I told you in videos 20 and 21, easements are made up of compound curves. Now, if you haven't seen videos 20 and 21, I recommend you check them out. They're just chock full of all sorts of easement info that you can use. So to make our easement, we need to get the endpoint angle here at this piece of track. And we already know that's 224.84 degrees. Then we're going to subtract 180 from that and we get 44.84 degrees. Now we need to get the end angle down here. So we'll click on that and we see that it is 52.84 degrees. So now we subtract 44.84 from 52.84 and we get 8 degrees. So go over here, select this piece of track, right click and select easement. Now we're going to enter 8 degrees for the angle and then we're going to set our radius to 1,524 millimeters. Now we're using 1,524 millimeters for the radius because our exit track is coming off of the larger radius curve in the curved turnout that we deleted. So we'll hit OK and we'll connect the easement to the end of the loop here. Now let's come up here and check the angle at the end of our easement, and we see it is 44.84 degrees. Now hover over this piece of track and take a look down at the bottom and see what its minimum radius is. Now in my case it's 110,459.48 millimeters. Now I'm going to go and grab the end. I don't have to hold down, whoops, move the whole thing. Do Control Z, put it back where it wants to be. I don't have to hold down Shift. It doesn't have to go in a straight line. I'm just going to bring it down and connect it up. And you'll notice it became part of our section and turned yellow. Now let's hover over that piece again and check our radius and make sure we didn't mess things up too badly. And it looks like we've got 62,822.81 millimeters. So I think that's going to be okay. Now let's get our grade set from here to here. And what I'm going to do is I'm going to turn on loop 3 just for reference. And I'll need to turn on the height as well because we're going to need to see that. Now here's our original turnout on the third loop, and here is our easement track right here. So if we look at this point and this point, they're essentially the same point. And as you can see, this is 265.53 millimeters, and this is 367.53. So we still have our 102 millimeter separation per loop at this point. So what we'll do next is we're going to smooth slope, starting with our easement here, all the way up to this piece of track here. We don't want to include this one. We want this one to be flat at 408 millimeters. So we will select that one, and we'll hit smooth slope. And we can see we get a 1.9% grade. Now, if we look at the end of our turnout here, it's somewhere around 270, and it looks like it might be 0.37, something like that. And if we look over here, we see we have 373.62 millimeters. So this means that our grade separation is now 103.25 millimeters, or 1.25 millimeters more than our 102 millimeters per loop that we wanted. But they're not in the exact same place, so I wouldn't worry about it. Now, by the way, this works out to 0.049 inches for those of us who use that system. Okay, now all we have to do is come over here, grab this piece, connect it to the end of our third loop, let it snap into place, and there's our helix. So let's take a look at it. Let's go over here. We'll turn on the second loop, the first loop, and the entrance track. And now that we have every layer on, you can see that every succeeding layer in our helix seems to line up exactly over the other one. So you don't have to worry about that track coming in, working its way in. Let's go to 3D, and you can admire your handiwork. All right, let's go back to 2D. Well, that was pretty darn complicated, wasn't it? But I've tried this method several times, and each time I do it, I refine it a little bit here and a little bit there. And I think this might be the final version, and I think what I showed you here is a pretty good method that should work for you. Now, I hope this helps you with any odd helix design you may want to come up with. Now, if you do design something that's out of the ordinary, leave a comment and let everyone know what you did. Now, in the next video, I want to talk a little bit about the Peco and Walther's curved turnouts and a possible error I found in the Walther's turnouts. And I'll also show you that track plan that I tried to design and how I failed miserably at it. All right, we'll see you soon.